Hello and welcome to Sacramento City College Chem 300 Lab in the time of COVID-19. I'm going to be demonstrating two types of chemical reactions for you today. Some of you, these are the same ones you were going to do yourselves until we had to shelter in place and start this temporary remote instruction mode. So these reactions are the ones described in your lab manual beginning on page 139 and then going through page 150 plus 151, I guess. These first five reactions are examples of what are called double displacement reactions. These reactions and the single replacement reactions will be described by your lab instructor when you meet with them during the regular lab period. All I am going to do is demonstrate each of these reactions sequentially, describing what I'm doing and what I'm seeing for you, and also hopefully letting you see that too. So evidence for reactions that we're looking for are gas formation, precipitate formation, or heat being given off if there's a formation of covalent bonds. When a covalent bond is formed, the elements reacting to form the bond lose potential energy. They become more stable, and as they release that potential energy, it's generally liberated as heat. So again, we're looking for heat, bubbles, or precipitates. Let's start with the first reaction. Sodium chloride solution mixed with potassium nitrate, KNO3. I'm going to do this reaction in a test tube, so the volumes are a little bigger. I'm going to add the sodium chloride first, and let's get rid of this. And I've pre-marked my test tubes with a mark at 3 milliliters and another mark at 6 milliliters. The exact volumes aren't critical. We just want enough to be able to see what's going on. And if there's heat evolved, enough solution in the container that we can feel the heat. So again, I'm taking a 0.1 molar sodium chloride solution. Technical errors there. And I've added that to the test tube. The test tube contains about 3 milliliters of that material. And now I'm going to add 0.1 molar potassium nitrate. There's the potassium nitrate. And the test tube has not formed any bubbles. There's no precipitate. And I don't feel any heat. But just to be sure, I'm going to take a thermometer. The thermometer is currently reading 17 degrees Celsius. And I'm going to just stick it in the solution for a minute or two. And I'm looking to see whether there's a temperature change. I don't really see one. So that was our first attempted reaction. And I didn't see any evidence of a reaction there. So sodium chloride plus potassium nitrate, I would say that gave us no reaction. Okay, now this is a 3-well plate. So I'm trying to figure out the best way to display it. And I'm going to mix iron 3 chloride and then ammonium hydroxide. And I'm going to do all 3 wells. I'm going to put a few drops of iron 3 chloride in the first two wells, so you can see what it looks like. It's a pale yellow solution. And then I'm going to add the ammonium hydroxide solution to it. Okay, that was about 5 drops of iron 3 chloride, and I'll put about the same amount of this ammonium hydroxide in it. Now notice, and I'll just put some of the ammonium hydroxide in that well as well, pun intended. Now notice in this case, the iron chloride was this pale yellow color in the middle. The ammonium hydroxide was completely clear. But when we mix the two together, there's a sort of a rust red precipitate that formed in that. So that's clearly evidence of a reaction. All right. So to summarize, iron 3 chloride mixed with ammonium hydroxide forms a reddish precipitate. Now I'm going to clean this one up. I'm just rinsing out my plate off camera so we can use it again. All of this waste at the end of the lab goes into a waste container. Right now it's just going into a beaker. All right. So next one on our list is sodium carbonate mixed with hydrochloric acid. Sodium carbonate and hydrochloric acid. Okay. So I'm going to put the acid in the plate first. Again, just about 5 drops. And I'll put it in the first 2 wells. Get rid of that bubble there. And again, the volumes aren't critical. And what we're looking for is, again, heat or a precipitate like we saw in that last reaction, or bubble formation. All right, here comes the sodium carbonate. And this is hard to see in this, but there's bubbles forming. I'm going to do this. I'm going to repeat the experiment in a test tube where we can see larger volumes. But I think, wait a minute, no, it's pretty tough to see the bubbles in this volume. Okay, we're going to do the experiment one more time with a test tube. And I am putting about 3 milliliters of the hydrochloric acid into this test tube. And now I'm going to add the sodium carbonate. Here goes the sodium carbonate. I don't know, you can see bubble formation on the sides of the test tube. See whether you can see that any better over here. I think so. Yeah, bubble formation. Don't laugh. It's actually getting a little warm too. Take my trusty thermometer again. And it's reading about 17 degrees here. And it's slightly warmer. It's about 19.5 degrees, maybe 20 degrees right now. So not only was there bubble formation in that reaction, it's still bubbling, but there was also heat generation. So that was the third reaction. That was sodium carbonate and hydrochloric acid. And that also had a reaction. We saw bubble formation, and we saw the temperature got warmer of the solution in the test tube. I couldn't have really stuck the thermometer in the test plate because it wouldn't have immersed fully. All right, our fourth reaction is the combination of copper sulfate and barium nitrate. So I'm going to put the copper sulfate in first. And again, I'm putting it in 2 wells so you can see what the copper sulfate looks like. This is copper 2 sulfate. There are 2 forms of copper sulfate, copper 1 and copper 2. This is copper 2 sulfate. All right. So now, I'll take the barium nitrate, and again, I'm going to add it to 1 well so you can see what it looks like. It's a clear solution. The copper sulfate was a pale green solution. That's in these 2 wells, this well and this well. This is barium nitrate, and then I'm going to add barium nitrate to the middle well. And there's clearly a precipitate forming there. Although on a white background, again, it's a little tough to see. So I think what I'll do is just pull this over a little bit, and then I'm going to move my camera. Again, this was the copper sulfate, this was the barium nitrate, and this is the copper sulfate plus the barium nitrate mixed together. And again, clearly a precipitate forming. It's kind of a cloudy white precipitate. And it's, so I let it sit there, it's kind of continuing to form and settle at the bottom of the plate. So reaction number 4, definitely positive results. All right. I'm going to clean out my plate off camera here again. And then the last reaction we were asked to do in another test tube. So that's sodium hydroxide and hydrochloric acid. Now, hydrochloric acid is a strong acid, and this is fairly concentrated. So I have my goggles on for safety's sake. Actually, I had my goggles on the entire time, but you can't see me. And again, I'm going to add the acid to the sodium hydroxide. I'm preparing those solutions off camera now, just adding them to 2 test tubes. You don't really want to see me do that, I don't think. All right. I've got 2 test tubes prepared, one with the sodium hydroxide and one with the hydrochloric acid. And all I'm going to do now is pour the sodium hydroxide into the hydrochloric acid test tube. Here we go. Trying to set it up so you can see and I don't spill at the same time. All right. I can see mixing lines. I do not see any evidence of bubbles or precipitate. I'm mixing now. This is a good trick for mixing. If you hold the top of the test tube firmly and flick the bottom, it mixes the two solutions together, but it doesn't come flying out the top of the test tube. All right. I can feel the test tube is getting warmer though. So again, my thermometer is reading 17 degrees, which is room temperature. Right now, this room's quite cool. And I'm sticking it in and oh yeah. Yeah, we're up to 25, 26, 27, 29. Baby's getting hot. 29.3 degrees. So clearly some heat being given off in this reaction. I don't know whether you can see very well, but the temperature started at 17 degrees, rose to nearly 30 degrees, 29.3 or 29.4. No precipitate. Here, I'm going to turn my camera sideways. No precipitate, no bubbles, but plenty of heat in that last reaction. Plenty of heat. So which reactions of these, just to summarize, did we see evidence of a reaction? Well, the first one, no precipitate, no bubbles, no temperature change, right? You could write those in over there. Second reaction, and that was sodium chloride plus potassium nitrate. Second reaction was iron 3 chloride with ammonium hydroxide. And in that reaction, we saw a rust red precipitate form from the starting solution of iron chloride, which was pale yellow. Third reaction was sodium carbonate plus HCl. And that one I did 2 times, one in the little plate and then a larger one in the test tube, because it was a little hard to see the bubbles in the plate because of the video camera stuff. I could see them, but I wasn't sure you could. So it was clearly forming bubbles when I did it larger volume in the test tube. This next one was copper sulfate mixed with barium nitrate. And in that reaction, the pale blue copper sulfate reacted with the barium nitrate and formed a white precipitate. And then in the last experiment, we took sodium hydroxide solution and mixed it with HCl. And when I did that, there was no precipitate, no bubble formation, but quite a bit of heat developed. It wasn't too hot to touch, but clearly it went from about 17 degrees centigrade up to nearly 30 degrees centigrade. So those are the double displacement reactions. I'm going to pause now and get set up for the single replacement reactions. I'll be right back. Okay, we're back, and now we're going to do the second half of the reaction lab. These are reactions of a metal and then a metal salt solution. So the 6 reactions that are being done here are copper metal, solid copper metal with a silver nitrate solution, solid lead with a copper nitrate solution, zinc solid with lead nitrate, copper solid with sulfuric acid. That's actually not a metal salt solution, that's a strong acid. The 5th reaction is solid zinc with magnesium sulfate. And the last one is zinc, solid zinc with sulfuric acid again. So I've previously polished all the pieces of metal to take any metal oxides off the surface. So we have pure metal in those reactions. Okay, I'm going to move the plates over. So here's, let's see, let's turn it this way. Here's the plate containing copper. Here's a plate containing lead. Center that a little bit. And here's a plate containing zinc. All right. So the first reaction we're called on to do is to take solid copper and silver nitrate. Now, silver nitrate is a clear liquid, but the silver in silver nitrate will react with your skin or your clothes and stain them black. If it's on your clothes, it's forever. If it's on your skin, you got to wait for the black spots to wear off your skin. So I'm going to add a few drops of this to my shined up copper. Oh, and you can see right away, get rid of those little bubbles. Those came from the dropper. You can see right away the difference between the copper on the left-hand side here and the just plain copper on the right. The copper on the left immediately developed a precipitate, a blackish, silverish coating. And that's getting thicker as I watch it. So clearly a distinct difference between the plain copper and the copper in the silver nitrate solution. That's reaction number one. Evidence of the reaction is a precipitate forming. And although it started off looking black, it's looking quite silvery. And you can't see this, but I can see these beautiful little needle-like crystals growing. I'm not sure this is going to work. I'm going to move the plate closer to the camera. Unfortunately, I think it gets out of focus, but you can see that the two look very different. Okay, our next reaction is in the middle plate, and I've got a piece of lead here that I shined up, and just for comparison purposes, there's another piece of lead over on the right-hand side that I did not polish. And I'm asked to put copper nitrate in this. This is copper 2 nitrate. Silver was silver 1 nitrate. All right. So again, I'm going to put drops of this blue copper nitrate solution into the well with the lead. And we're going to wait for a while, see what we see. And my shiny lead is not so shiny anymore. I don't want to stick my nose in the camera. It's forming a black precipitate on the lead. Black precipitate when I mix lead and copper nitrate. Yep. Okay. Reaction number 3 is zinc. The elemental zinc. It's over here. And we're asked first to add lead nitrate to that. So I got shiny pieces, 3 shiny pieces of zinc and another piece of zinc over there just for comparison purposes. So here's the third reaction, which is zinc metal plus lead 2 nitrate. Oh, and once again, we got quite the strong reaction there. An immediate formation of a black precipitate on the zinc. And I think you can clearly see the difference between those two. The right-hand side would be the just plain zinc metal. Left-hand side is the metal to which I added the lead nitrate. Now, we're going to go back to the plate that I have copper in because I'm asked to do another experiment using 3 molar sulfuric acid. And so I've got my acid just off camera here, and I'm going to add the sulfuric acid to this bottom well, which has a polished piece of copper. I'm getting my pipette with the acid. Now I'm adding the acid. And I am not seeing any precipitate. And I'm not seeing any bubbles. And I can't stick my finger in there to see whether it's getting hotter, but I don't think I see a reaction there. Okay. Meanwhile, if you come back and look at this silver nitrate with the copper, these crystals are just gorgeous. They're beautiful, shiny silver crystals. It's going to be a shame to dispose of that. Okay, so that was reaction number 4, copper plus sulfuric acid down here. And I'm not seeing anything there at all. Okay. Next reaction is zinc metal with magnesium sulfate. So over here on my zinc plate, you can see that the zinc that we mixed with the lead nitrate had a really strong black precipitate forming. I'm going to add the magnesium sulfate to the middle well, which has another piece of shined up zinc. Okay, here we go. Okay, that's magnesium sulfate added to a well with a piece of zinc in it. And I am not seeing anything happening in that well. There's clearly no precipitate. My zinc looks pretty much the same as it did before. I'm looking carefully for bubbles, and I'm not seeing any bubbles either. All right. So reaction number 5, zinc plus magnesium sulfate. I'm not seeing a reaction there at all. We're going to give it some time. While we're doing that, I'll do the last reaction, which is to take that last piece of shined up zinc in this well here, and I'm going to add sulfuric acid to that. Now remember, when we put sulfuric acid in with copper, that's this. There was no evidence of a reaction, no bubble formation, no precipitate, nada. We'll see what happens when I take the same sulfuric acid and add it to my piece of zinc. Here we go. Oh yeah, baby. Now, I do see, but can you see? Let's see what that, yeah. I don't think you guys can see this too well. What I see, we'll give it some time. What I see is bubbles forming on the surface of the zinc and then rising to the top. I think I'm going to repeat this experiment in a test tube so that you guys can see what's going on. Okay, so I'll take my sulfuric acid, carefully add it to the test tube here. Sorry, I'm off camera. You'll just have to trust me on this one. I have to go get another piece of zinc, which, oh, I have a piece of zinc right here. Never mind. I'll just grab that one and drop it in. This illustrates something that I hadn't intended to talk about, but let's see. I'm going to move the lead out of the way and see whether you can see in the test tube. You can see bubbles forming on the surface of the zinc. Let me see if I can add some contrast to this by bringing it over a lighter surface or a darker surface. Not sure which one of those is better. I could also just bring it closer. There are bubbles forming on the surface of the zinc. Periodically, they're breaking off and rising to the top of the test tube. This is a little easier to see than it was in the plate. All right. So, to summarize, let me move these off, get back to our thing. Check out one last look at that silver. Isn't that gorgeous? Well, it's gorgeous to me anyway. Okay. Summarizing our reactions. When we mixed the copper with silver nitrate, we got growth of crystals, silver crystals, all over the surface of the copper. When we mixed the lead with copper nitrate, we got a black precipitate forming on the surface of the shined up lead. When we mixed zinc with lead 2 nitrate, we didn't see any reaction at all. Again, that's this center well here, zinc plus the lead 2 nitrate. When we mixed copper with sulfuric acid, it's this one, no reaction at all. Still not doing anything. Very stubborn. By contrast, you can kind of see the bubbles. I can see the bubbles pretty clearly now. I don't know whether you guys can, though. It's a little hard to see. When you mix the zinc or put the zinc in sulfuric acid, bubbles are forming on the surface of the zinc. Here's normal zinc. Here's the zinc with the bubbles forming on it. So there was clearly evidence of reaction here, right? There was clearly evidence of reaction there. No reaction of zinc with lead nitrate. No reaction of copper with sulfuric acid. No reaction of zinc with magnesium sulfate, but clearly a reaction of zinc with sulfuric acid. All right, that concludes the experiments for the single and double replacement reactions for CHEM 300. And I hope you enjoy the rest of your semester. Have a good day.